1019F1015. I am from DKA 5 Section 2. I am a student majoring in Diploma in Civil Engineering.
Hi, my name is Alicia Anagalan. My register number is 05DKA19F1018. I'm from DKA 5 Section 2 and I'm a majoring student in Diploma in Civil Engineering.
Hi, my name is Elatio Yichen and my matric number is 05DKA19F1094.
The objective for our final year project are to propose the percentage of cement accelerator in the cement mixture, to determine the strength of the concrete when added alternative admixture, and to analyze the feedback about the cement mixture with the addition of cement accelerator from the concrete user. Meanwhile, the scope of our study are to observe the strength, time and cost taken, to observe the effectiveness of the additive and the differences from other cement, to evaluate the performance through compressive strength tests. First of all, install the concrete cube mold. The cost aggregate is sieved to get 10 mm and 20 mm cost aggregate. Based on this concrete mix design form, we can see these are the weight of materials that we need for our concrete mix. We need 1.15 kg of cement, 0.54 kg of water, 1.74 kg of fine aggregate, 1.56 kg of 10 mm coarse aggregate and 3.13 kg of 20 mm coarse aggregate. The sand, cement, and coarse aggregate was weighing on the weighing balance based on the concrete mix design that we have calculated. All the materials are labeled inside a metal tray. Make sure each concrete cube mold has the same weight of materials. All of the materials are mixing on a metal tray until the mixture is roughly blended. The cube mold has been cleaned, then grease is applied inside the concrete cube mold. Fill the concrete mixture in the molds in layers approximately 5 cm thick. Each layer of cement mixture is compacted with not less than 35 strokes per layer using a tamping rod. Then, level the top surface and smoothen it with a trowel. All the test specimens are stored in moist air for 24 hours, and after this period, the specimens are marked and removed from the molds and kept submerged in clear fresh water until taken out prior to the test. The water for curing should be tested every 7 days, and the temperature of the water must be at 27 degrees Celsius and below. Repeat all the procedures for each sample that added with sodium nitrate with different percentage, which is 1.5%, 2.5% and 3.5%. The first specimen, which were a cube without any additional chemical mixture from the water after 7 days curing time and wiped out excess water from the surface. The cube was weighed on the weighing balance and the mass of the cube was recorded. The cube was placing in the machine in such a manner that the load shall be applied to the opposite sides of the cube cast and align the cube centrally on the base plate of the machine. 150 kN load is applied gradually without shock and continuously at the rate of 13.5 kN per second until the specimen fails. The compression test has started and the load began to crush the cube. The maximum load is recorded and any unusual features in the type of failure is noted. Repeat all procedures for different specimens with additional 1.5%, 2.5% and 3.5% sodium nitrate, and for the next different days, which is 14 days and 28 days. Record the percentage of gain strength in a table for 7, 14 and 28 days cube by using the right formula. From this compression strength table, we can conclude that 2.5% of sodium nitrate achieved the highest compression strength for M30 grade concrete. This graph shows the reading of the compressive strength for 7 days, 14 days and 28 days increase until 2.5% of sodium nitrate and decrease afterwards. For example, on the sample of 1.5% of sodium nitrate, it kept increasing from 5.20 MPa up to 8.15 MPa and dropping down to 7.96 at 3.5% of sodium nitrate. This indicates that it has reached its maximum compressive strength, which is at 2.5% of sodium nitrate, and the hydration energy has come to an end. Now let's move to the cement consistency test by VICAT test. The objective of this test is to find the basic required quantity of water to form a cement paste as specified by IS code 4031, which the VICAT plunger will penetrate to 5 until 7 mm point to the bottom of VICAT mold. The standard consistency of OPC is between 25 until 30%. For example, to calculate the amount of water required for a 400 gram of cement which has 25% consistency, so we multiply 400 gram of cement with 25%, so we got 100 gram or 100 milliliter. 100 milliliter water is needed to conduct the test. First, 400 gram of cement was weighing on the weighing balance. Then 100 ml of water added with the cement and mixed well for 3 until 5 minutes. Grease is wiped inside the VICAT mold and on the glass plate to avoid the cement from sticking inside the VICAT mold and on the glass plate for a long time. The VICAT mold is filled with cement paste, which is placed on the glass plate. Ensure to compact the paste well after filling the mold. Fill the cement paste to the top of the mold. The excess paste was removed by the trowel. Install the plunger and the VICAT mold placed under the plunger. Then the plunger was released so it penetrates the cement paste inside the VICAT mold. After releasing the plunger, wait for 3 seconds and note down the penetration reading. Since this is a test and error, if the reading for OPC exceeded the standard depth with each 5 until 7 mm, repeat the test consistency until the reading lies between 5 until 7 mm from the bottom of the VICAT mold. The test is repeated by mixing the cement with different weight of water. From this table, we can conclude that the consistency of cement is 30% because the condition of cement consistency test is the penetration reading must be lies between 5 until 7 mm. For the last test is setting time test. First, 400 gram of cement was weighing on the weighing balance. Then 100 ml of water added with the cement and mixed well for 3 until 5 minutes. Grease is wiped inside the VICAT mold and on the glass plate to avoid the cement from sticking inside the VICAT mold and on the glass plate for a long time. The VICAT mold is filled with cement paste, which is placed on the glass plate. Ensure to compact the paste well after filling the mold. Fill the cement paste to the top of the mold. The excess paste was removed by the trowel. This is well known as initial needle. Install this initial needle to test the initial setting time. The mold is placed at VICAT apparatus after 30 minutes and the plunger was released. Wait for 3 seconds and note down the reading. Repeat the procedure after 110 minutes, which is the 140th minutes. After we have done with initial setting time, replace the needle with the final needle with a annular attachment to test the final setting time. After waiting for 40 minutes, release the plunger and record the penetration reading. Repeat all the procedures for each sample that added with sodium nitrate with different percentage, which is 1.5%, 2.5% and 3.5%. From this table, we can conclude that the cement hardened quickly when 2.5% is added with the cement mixture. This graph shows that 2.5% of sodium nitrate encourage the cement to harden because the penetration reading is increased from time to time. As you can see, the price for rapid hardening Portland cement is 100 ringgit per bag. Meanwhile, if you use OPC plus sodium nitrate, you only spend 45 ringgit per bag. For our final year project, we only spend 1 ringgit and 64 cents for 1 cube. After we analyze the feedback, there are 100% of respondents agree that sodium nitrate can increase the strength of concrete, and 94% of respondents choose sodium nitrate as the concrete hardening accelerator instead of buying the expensive rapid hardening Portland cement. Last but not least, the impact of our final year project are: it can reduce the cost of concrete works, saving the concrete users time, increase the purchase rate of sodium nitrate and OPC, increase the productivity of concrete works. That's all for our final year project video. Thank you for watching.